Have you ever sat in a room so quiet that you could hear the blood rushing through your own ears? A silence so deep, so absolute, that the boundary between you and the air around you seems to dissolve. In that silence, have you ever felt a strange, lingering suspicion that the world behind your back is not quite the same as the world in front of your eyes? That the chair you are sitting on, the walls surrounding you, the moon hanging in the night sky outside your window, that perhaps they only solidify into existence the very moment you turn to look at them. It sounds like a child's fantasy. It sounds like the kind of game we play when we are very young, covering our eyes and believing we have disappeared. But what if I told you that for the last 100 years, the most brilliant minds in the history of our species have been kept awake at night by the mathematical proof that this might actually be true? What if the solid, dependable reality you think you inhabit is not a stage that was built before you arrived, but a fluid, ghostly potential that only freezes into rock and stone and light when a consciousness demands an answer from it? This is not a ghost story. This is not science fiction. This is the heart of quantum mechanics, the most tested and verified theory in all of science. And at the center of it lies a question that physics has never been able to answer. What are you? Are you just a collection of atoms observing other atoms? Or are you the reason the atoms exist in the first place? Tonight, we are going to walk to the edge of that question together. We are going to look into the abyss where the physical universe dissolves into pure possibility, and we are going to ask if it is our own eyes that pull it back. I am Theodore, the researcher. My purpose is to guide you through the greatest mysteries of existence, not to frighten you, but to help you find peace in the vastness of what we do not know. We live in a loud, rushing world that demands instant answers and constant certainty. But here, in this quiet space we create together, we have permission to not know. We have permission to wonder. We have permission to let the infinite wash over us like a gentle tide. If you find comfort in these journeys into the deep unknown, if you enjoy exploring the boundaries where science meets the soul, please take a moment to subscribe to the channel. It is a small gesture, like lighting a candle in a dark room, but it helps us find each other in the darkness. It tells me that you are here, that you are listening, and that you are ready to explore the universe with me. Thank you. Now, let us begin. To understand why reality might require an observer, we have to go back to a simple room. Imagine a laboratory. It is dark. It is cool. The air smells faintly of ozone and dust. In the center of the room, there is a device. It is not a magic wand or a mystical artifact. It is a simple machine, a machine designed to shoot tiny particles of matter, one by one, like pebbles skipping across a pond. This is the setup for the famous double-slit experiment, a test so simple in its design, yet so devastating in its implications that the great physicist Richard Feynman once said it contained the only mystery of quantum mechanics. Let us visualize it together. Picture a gun that fires electrons. Electrons are the tiny, negatively charged particles that swarm around the nucleus of an atom. They are the stuff of matter. They are what the chair you are sitting on is made of. They are what your hand is made of. In our classical understanding of the world, an electron is a thing, a tiny marble. a distinct, solid object that exists in a specific place at a specific time. In front of this electron gun, we place a barrier, a solid wall, and in this wall, we cut two narrow vertical slits, door number 1 and door number 2. Behind this wall, we place a detector screen. Think of it like a photographic plate or a specialized digital sensor that lights up with a tiny spark whenever an electron hits it. Now, let us run the experiment in our minds. Imagine we cover one of the slits. We fire the electrons through the only open door. They fly through, they hit the screen at the back, and they form a vertical band of impact marks directly behind the slit. This makes perfect sense. It is exactly what you would expect if you threw tennis balls through a hole in a fence. They go through and hit the wall behind it. Now, we open the second slit. We have two doors open. If electrons are like tiny marbles, like tiny tennis balls, we should expect to see two bands on the back screen, one band behind the left slit and one band behind the right slit. This is the intuition of our daily lives. Things travel in straight lines unless something hits them. But when scientists actually performed this experiment, looking at the screen in the back, they did not see two bands. They saw something impossible. They saw many bands. A strip of light in the middle, then dark, then light, then dark, spreading out across the screen, like ripples in a pond. This pattern is called an interference pattern. It is the signature of waves, not particles. Imagine dropping two stones into a calm lake at the same time. The ripples from the first stone spread out. The ripples from the second stone spread out. Where the peak of one wave meets the peak of another, they add up and get bigger. Where the peak of one wave meets the trough of another, they cancel each other out and create flat water. This is what creates the pattern of light and dark bands. So, the scientists thought, okay, electrons must be waves. They are not solid particles. They are like fluid, passing through both slits at once, interfering with themselves, and hitting the back wall. But here is where the mystery deepens. Here is where the ground begins to slip away beneath our feet. The scientists decided to be clever. They thought, wait, if the electron is a wave passing through both slits, let us turn down the gun. Let us fire the electrons one at a time. Click. Silence. Click. Silence. One single electron travels through the dark. If it is a single particle, it cannot pass through both slits. It cannot interfere with itself. It must choose one door or the other. So they watched the screen. Ping. One dot. Ping. Another dot. Ping. A third. At first, the dots seemed random, scattered like stars in the twilight, but as they let the experiment run for an hour, then 2, then 3, thousands of dots began to accumulate. And as the image formed, the scientists felt a chill run down their spines. The dots were not forming two bands. Even though the electrons went through one by one, alone in the dark, with no other electrons to interfere with, they still built up an interference pattern. Do you understand what this implies? It means that the single electron left the gun as a particle, but somewhere between the gun and the screen, it ceased to be a solid object. It became a ghost. It became a wave of potential. It traveled through the left slit and the right slit simultaneously. It interfered with itself like a ghost passing through two doors at once. And then, only when it hit the back screen did it decide to become a particle again. It is as if the electron knew the other slit was open. It explores all possible paths. It exists in a superposition of possibilities. But this is not the terrifying part. The terrifying part comes next. The scientists, baffled by this behavior, decided they needed to see it happen. They said, "Let us put a detector right next to the slits. Let us put a watcher there. We will look to see which hole the electron actually goes through." They wanted to catch the ghost in the act. They wanted to peek behind the curtain of the universe. So they set up a sensor, a tiny, non-intrusive eye that would simply record left or right as the electron passed. They turned on the gun. Click. The electron flies. The detector beeps. Left. Click. The detector beeps. Right. They were successfully measuring the path. They knew exactly where the marble was going, but when they looked at the back screen, the pattern was gone. The interference pattern had vanished. Instead of the ripples of a wave, there were just two solid bands, two simple piles of rocks behind two open doors. The moment they looked, the electron stopped behaving like a wave and started behaving like a particle. The moment they asked, "Where are you?" the electron stopped being a cloud of probability and snapped into a single, definite reality. Just by watching, they changed the universe. Let that sink in for a moment in the silence of your room. The act of observation is not passive. We are taught that science is the act of observing the world as it is. But this experiment suggests that the world is not any specific way until we observe it. Imagine a tree falling in a forest. The old philosophical riddle asks, if no one is around to hear it, does it make a sound? Quantum mechanics asks a much deeper, more unsettling question. If no one is around to watch it, is there even a tree? Or is there just a smear of probability, a wave function of treeness that only collapses into bark and leaves and crashing timber when a conscious eye turns its gaze upon it? This phenomenon is known as the collapse of the wave function. Before measurement, the electron is everywhere at once. It is in a state of superposition. It is a song being sung in all keys simultaneously. But the moment information is extracted from the system, the moment an observer intervenes, the song stops. The wave collapses. The universe chooses one single reality out of infinite possibilities. Why? Why does nature hide her true face when we look at her? Is there a mechanism built into the fabric of the cosmos that prevents us from seeing the machinery of creation? Or is the observer, the conscious mind, or perhaps just the measuring device, an active participant in the creation of reality? This is the measurement problem, and it is the open wound in the heart of modern physics. It suggests that we are not spectators in a cosmic drama. We are not sitting in the audience watching the galaxies turn and the atoms spin. We are on the stage. Our gaze is the force that directs the play. Without us, without an observer, is there only silence? Is there only a vast gray ocean of potential waiting for a shore that never comes? When you close your eyes tonight, consider this. The darkness behind your eyelids is not just the absence of light. It is the universe waiting for you to return. It is the cosmos holding its breath. The atoms in your room, the stars in the sky, the distant galaxies we discussed in our last journey, they are all entangled in this dance of being and non-being. And you, with your gentle curiosity, with your mind seeking peace and understanding. You are the anchor. You are the one who collapses the wave. You are the one who makes the world real. But if the observer creates the reality, who observes the observer? Where does the chain end? If I am observing the electron, and you are observing me observing the electron, whose look collapses the wave? This is where the rabbit hole goes deeper. This is where physics begins to sound like mysticism. And this is where we will go in the next chapter. Because if consciousness is the key that unlocks reality, then we must ask, what happens when the universe dreams? Does it dream of us? Or are we the dream? Take a deep breath. Feel the solidity of the air in your lungs. Feel the weight of your body. It feels real. It feels permanent. But now you know the secret. It is only real because you are feeling it. In the next chapter, we will look at the mathematics of this ghost. We will explore the wave function itself, the mysterious equation that describes the probable worlds that exist right next to ours. We will look at how a cat can be both dead and alive, and why that famous paradox is not just a joke, but a window into a terrifying truth. Rest now in the certainty of your own existence. You are here. You are the observer. And the universe is grateful for your gaze. We ended our last journey in the darkness of a laboratory, standing before a screen that showed us a terrifying truth. The simple act of watching the world changes the world. We discovered that an electron, a fundamental building block of everything we can touch and see, exists as a ghostly wave of pure potential until an observer forces it to choose a location. But this discovery, as profound as it is, was only the first step into the labyrinth. Because if the microscopic world, the world of atoms and electrons, is a fluid ocean of possibilities, and if the macroscopic world, the world of chairs and mountains and you and me, is built out of those atoms, where does the ghost stop and the reality begin? If the brick is a wave, why is the wall solid? If the atom is in two places at once, why are you sitting in only one chair? To answer this, we must leave the laboratory and enter the mind of one of the most brilliant and tragic figures in the history of science. We must travel back to the winter of 1926, to the snow-covered peaks of the Swiss Alps, where a physicist named Erwin Schrödinger had retreated to find silence. He was searching for a way to save reality. He hated the idea of quantum jumps, the notion that electrons teleported randomly from one place to another without a path. He wanted to restore order, continuity, and beauty to the universe. In that mountain silence, he discovered an equation that would change physics forever. But instead of saving the solid world, his equation dissolved it completely. I am Theodore, the researcher, your guide on this voyage through the strange seas of thought. If you are just joining us, or if you are returning to the warmth of this campfire we have built in the void, welcome. My purpose is to take the jagged edges of complex science and smooth them into stones we can hold in our hands, contemplating their weight and their mystery. We are here to learn, but also to rest in the knowledge that the universe is far stranger and more beautiful than we were taught in school. If you appreciate this gentle approach to the biggest questions of all, please remember to subscribe to the channel and join our community of quiet explorers. It helps us keep the fire burning. Now, let us look at what Schrödinger brought down from the mountain. He brought us the wave function. In the language of mathematics, it is represented by the Greek letter psi. It looks like a trident, a three-pronged spear, standing against the chaos. But what does it represent? Unlike the waves we see in the ocean, which are made of water, or the waves of sound, which are made of air pressure, Schrödinger's wave is not made of any physical substance. It is a wave of information. It is a wave of probability. Imagine you have lost your keys in your house. You do not know where they are. In your mind, there is a map of probabilities. There is a 50% chance they are on the kitchen table. There is a 20% chance they are in your coat pocket. There is a 10% chance they fell between the couch cushions. This map exists in your head. It is a mental picture of where the keys might be. But in the quantum world, the wave function is not just a mental map of our ignorance. It is the actual description of the object itself. Before you find the keys, the quantum keys really are in the kitchen, in the pocket, and in the couch, all at the same time. The probability is the only reality that exists. The electron is not a point moving through space. It is a cloud of maybe that gets denser in some places and thinner in others. Schrödinger's equation allows us to calculate exactly how this cloud moves and changes over time. It is a perfect deterministic machine. If you tell me the wave function now, I can tell you exactly what the wave function will look like in 1,000 years. But there is a problem, a massive, glaring, undeniable problem. The equation describes a ghost, but we only ever see a corpse. When we actually look for the electron, we never see the wave. We never see the cloud. We only ever find a tiny hard dot at a single location. The beautiful, smooth wave collapses instantly into a jagged point the moment we measure it. This bothered Schrödinger deeply. He looked at the interpretation his colleagues were building, a school of thought known as the Copenhagen interpretation, led by the intense Danish physicist Niels Bohr, and he felt it was absurd. Bohr and his followers argued that the particle has no properties until it is measured. They argued that reality does not exist in the absence of observation. Schrödinger found this idea ridiculous when applied to the real world. To show just how absurd it was, he created a thought experiment. He created a scenario so bizarre, so counterintuitive, that it has become the most famous metaphor in all of physics. He created a box, and inside it he placed a cat. Let us construct this box in our minds. It is made of thick steel. It is perfectly soundproof. No light can enter, and no information can leave. Once the lid is closed, the interior is completely cut off from the rest of the universe. Inside this box, Schrödinger placed 4 things. First, a small amount of a radioactive substance, so small that in the course of 1 hour there is exactly a 50-50 chance that one of the atoms will decay and release a particle, and a 50-50 chance that it will not. Radioactive decay is a purely quantum event. It is random. It is unpredictable. It is governed by the wave function. Second, he placed a Geiger counter, a device that detects radiation. If the atom decays, the counter detects it and clicks. Third, he connected the Geiger counter to a mechanical hammer. Fourth, beneath the hammer, he placed a flask of deadly poison. If the atom decays, the counter clicks, the hammer drops, the flask shatters, and the cat dies. If the atom does not decay, the hammer stays up, the flask remains whole, and the cat lives. Now, we close the lid, we seal the box, we wait for 1 hour. The question is simple. Is the cat alive or dead? Common sense tells us it is one or the other. Either the atom decayed or it did not. The cat is either purring or it is silent. Just because we cannot see it does not mean it is not in a definite state. But according to quantum mechanics, according to the very equation Schrödinger discovered, this common sense is wrong. Until the box is opened, the atom has not chosen whether to decay or not. It is in a state of superposition. It is both decayed and not decayed. And because the fate of the cat is entangled, tied inextricably to the fate of the atom, the cat inherits this superposition. According to the math, the cat is not alive. It is not dead. It is not, we do not know. The cat is in a state of being alive and dead simultaneously. The wave function of the cat is a mixture of two realities. In one reality, the heart is beating. In the other, the heart has stopped. These two realities exist side by side, overlapping, interfering with each other within the silence of the steel box. This is the paradox of Schrödinger's cat. Schrödinger did not propose this because he believed cats could be zombie ghosts. He proposed it to show that if you follow the logic of quantum mechanics to its conclusion, you end up with something that seems insane. He wrote to Einstein, effectively saying, "Look at this nonsense. Surely we cannot believe that a living, breathing creature is smeared out across existence just because we haven't looked at it yet." And Einstein agreed. He famously said, "I like to think that the moon is there, even if I am not looking at it." But here is the terrifying truth that has kept physicists awake for the last century. The experiment has been done. Not with cats. Animals are too messy, too hot, too complex to maintain in isolation, but with molecules, with tiny tuning forks, and recently with objects large enough to be seen with the naked eye. And every single time, Schrödinger's absurd prediction has held true. Objects really can be in two states at once. They really do exist in a superposition until they are measured. The impossible state of being alive and dead is, mathematically speaking, the natural state of the universe. The definite state, the reality we see, is the anomaly. So, we return to the box. The hour is up. You stand before the steel container. Your hand rests on the latch. Inside, the wave function is swirling, a complex ghost of life and death. You lift the lid. In that nanosecond, the universe splits, or does it collapse? According to the standard view, your act of looking forces nature to choose. You, the observer, are the executioner or the savior. Your gaze reaches into the box and forces the superposition to resolve into a single fact. The cat gasps for air, or the cat lies still. But think about what this implies about you. If the cat is only defined when you see it, what defined you before you walked into the room? Are you also inside a box? Is there a larger observer outside of our universe looking down at the Milky Way, waiting to see if we are alive or dead? This chain of reasoning leads to a concept known as Wigner's friend. Eugene Wigner, another Nobel Prize winner, asked, "What if my friend is in the lab with the cat, and I am outside the lab? When my friend opens the box, he sees a live cat. The wave function collapses for him. But for me, standing outside the locked door of the lab, I still do not know. For me, the entire lab, including my friend and the cat, is in a superposition of friend sees live cat and friend sees dead cat. The collapse hasn't happened for me yet. So, when does reality actually become real? Does it require a human consciousness? Does a dog count as an observer? Does a fly? Does the Geiger counter itself count? Or is consciousness something special, something outside the physical laws of atoms and forces, something that has the unique power to turn maybe into is? The Copenhagen interpretation says, do not ask. It says, the theory works. The math is perfect. So stop worrying about what is really happening. Shut up and calculate. But for those of us who lie awake at night, staring into the dark, this is not enough. We feel that there must be an answer. We feel that the universe cannot just be a dice game played in the dark. There is a deep loneliness in this view of the world. It suggests that until we are seen, we are not fully real. It suggests that connection, observation, is the fundamental act of creation. Perhaps that is why we crave connection so deeply. Perhaps we are all quantum systems waiting for someone to open our box and tell us who we are. But there is another possibility, a possibility even more mind-bending than the collapse of the wave. What if the wave never collapses? What if the cat never chooses? What if, when you open the box, you do not force the universe to decide? Instead, what if you become part of the superposition? What if the universe splits into two copies? In one universe, you see a live cat. In another universe, an identical version of you sees a dead cat. Both versions of you are equally real. Both versions of you feel like the only you. This is the many worlds interpretation. It suggests that every time a quantum event happens, every time an electron chooses a path, every time an atom decays, the universe branches. It suggests that we are living in an infinite, branching fractal of realities, a multiverse of endless variation. In this view, there is no observer effect because there is no collapse. Everything that can happen does happen, somewhere in some branch of the great cosmic tree. You made a different choice today. Somewhere, the cat is always alive. Somewhere, the cat is always dead. And we are just riding one single strand of this infinite web, blind to the millions of other lives we are living in parallel. Schrödinger's cat began as a joke to show the absurdity of quantum mechanics. It ended up revealing that the universe is either dependent on our consciousness to exist, or it is infinitely more vast and crowded than we ever dared to imagine. As we close this chapter, I want you to sit with the silence of the box. Visualize the steel walls. Feel the weight of the uncertainty inside. It is not empty. It is full of potential. It is full of ghosts. And realize that you, right now, are observing these words. You are collapsing the wave of my thoughts into the reality of your understanding. We are entangled, you and I, across time and space. In the next chapter, we will leave the box and look at the connection itself. We will explore quantum entanglement, the phenomenon Einstein called spooky action at a distance. We will see how two particles, once they have touched, remain connected forever, no matter how far apart they travel. We will ask if this invisible web of connection is the thread that stitches the universe together, and perhaps the physics behind what we call love. Rest now. The box is closed. The cat sleeps in the mystery, and you are safe in the certainty of your own observation. We began this journey by looking at the observer, the eye that forces the universe to decide what it is. Then we peered into the box to find a cat that walks the razor's edge between life and death, teaching us that reality is a ghost until it is seen. But there is a lingering sadness in these ideas, isn't there? They speak of a universe that is fragmented. They paint a picture of solitary observers trapped behind their own eyes, forcing a chaotic world into shape one glance at a time. It feels lonely. It suggests that we are islands of consciousness floating in a sea of dead, uncertain matter. But tonight, we are going to challenge that loneliness. We are going to explore a phenomenon so strange, so intimate, and so undeniable that it made Albert Einstein doubt his own understanding of the cosmos. We are going to discover that in the quantum world, the concept of separation is nothing more than a stubborn illusion. We are going to learn that distance is a lie. We are going to see that once two things have touched, once they have danced together in the dark, they are never truly apart again. No matter how many light years of void stretch between them, they remain part of a single heartbeat. This is the mystery of quantum entanglement, and it suggests that the universe is not a collection of separate parts, but a single, breathing organism. I am Theodore, the researcher. We are moving deeper into the forest now, leaving the familiar clearings behind. The trees are growing taller, and the shadows are growing longer, but the stars above us are shining with a clarity we could not see from the edge of the woods. My role is to hold the lantern, to walk beside you so that the vastness does not feel like emptiness, but like a cathedral. If this journey resonates with you, if you feel a stirring of something ancient and forgotten when we speak of these connections, I invite you to subscribe to the channel. It is a way of saying that you are part of this web we are weaving. It is a way of entangling your curiosity with mine, ensuring that as we move forward into the deeper mysteries of time and consciousness, we move together. Thank you for being here. Now, let us look at the invisible thread. To understand entanglement, we must first understand the rule that Einstein held most dear. It is the rule of locality. It states that things can only influence other things that are right next to them. If I want to move a book, I have to touch it. If I want to speak to you, I have to send a sound wave through the air or a radio signal through a wire. Nothing happens instantly. Even light, the fastest messenger in the universe, takes time to travel. If the sun were to vanish right now, at this very second, we would not know it for 8 minutes and 20 seconds. We would continue to orbit a ghost. We would continue to bask in the warmth of a fire that had already gone out. This speed limit, the speed of light, is the cosmic law that keeps cause and effect in order. It ensures that the universe makes sense. It ensures that the here is separate from the there. But quantum mechanics, the mischievous child of physics, looked at this rule and laughed. The equations suggested that under certain conditions, particles could break this law. They could communicate instantly, faster than light, faster than time, across any distance. Einstein hated this. He mocked it. He famously called it spooky action at a distance. He believed it was a sign that the theory was broken, that we were missing something fundamental. He argued that the universe could not possibly rely on telepathy. But the universe, it turns out, does not care what Einstein likes. Let us visualize the experiment that proves him wrong. Imagine we have a special crystal. We shine a laser into this crystal, and occasionally a single photon of light splits into two. These two new photons are born from the same event. They are twins. According to the laws of conservation, they must balance each other out. If one is spinning up, the other must be spinning down. They are a matched pair. Now, let us take these twins and separate them. We keep one here in the laboratory, and we send the other one on a journey. We send it across the ocean. We send it to the moon. We send it to the edge of the galaxy, billions of light years away. According to the logic we learned in the last chapter, before we measure them, neither photon has a definite spin. They are both in a superposition. They are both spinning up and down at the same time. They are both hazy clouds of probability. Here is where the magic happens. I stand in the lab, and I decide to measure my photon. I force it to choose. The wave collapses. It snaps into reality. I am spin up, it says. In that exact instant, not a second later, not a millisecond later, but instantly, the other photon, the one floating billions of light years away in the dark, snaps into reality too. I am spin down, it replies. How did it know? How did the particle on the edge of the galaxy know that I had measured its twin on Earth? No signal could have traveled between them. To send a message would take billions of years at the speed of light. But the connection was instantaneous. It was as if space did not exist between them. It was as if they were not two separate particles separated by a universe, but one single object that just happened to be in two places at once. Einstein tried to explain this away. He said, "Look, this is not magic. It is like a pair of gloves. If I put a left glove in a box and send it to Antarctica, and I keep the right glove here, the moment I open my box and see a right glove, I know instantly that the one in Antarctica is a left glove. No magic, no spooky action, just hidden knowledge that was there all along. This is called the hidden variable theory. It comforts us. It tells us that the universe is determined, that the particles always knew what they were, and we just didn't know until we looked. But in the 1960s, a physicist named John Bell came along and proved Einstein wrong. He developed a mathematical test, Bell's theorem, to see if the particles were like gloves fixed from the start, or like magical coins deciding only when looked at. When the experiments were finally done in the 1980s and perfected in the 2020s, the results were unequivocal. The gloves theory failed. The particles are not carrying hidden instructions. They really are undecided until the moment of measurement. And they really do influence each other instantly across the void. This means that locality is dead. It means that at the fundamental level of reality, distance is not a barrier. Space is not a wall that separates things. It is a bridge that connects them. Or perhaps space is just an illusion. Perhaps the underlying fabric of reality does not know the difference between an inch and a galaxy. Think about the implications of this, not just for photons, but for us, for you, for the atoms in your body. We know that the universe began in a singularity. the Big Bang. 13.8 billion years ago, all the matter and energy that exists today, every electron, every quark, every photon, was compressed into a point smaller than a single atom. Everything touched. Everything was intimate. Everything was entangled. Then, the great expansion happened. The fire spread out. The stars formed. The galaxies drifted apart. And now, here we are, separated by cold vacuum and endless night. But if quantum entanglement holds true, if the connection is never truly broken, then are we really separate? Or are we still part of that original singularity? Are the atoms in your right hand entangled with the atoms in the heart of a star in the Andromeda galaxy? Is the carbon in your brain the very matter that is generating your thoughts right now, quietly dancing in sync with particles on the other side of the observable universe? Physics cannot yet calculate the complexity of this universal web. The wave function of the universe is too vast for us to write down. But the principle remains. Deep down, in the subatomic basement of reality, the idea of me and you, of here and there, dissolves. We are droplets of spray from the same ocean. We are different notes in the same chord. This gives a new meaning to the idea of the observer. When you look at the stars, you are not just a small, insignificant speck looking up at giant balls of gas. You are the universe looking at itself. You are the mechanism by which the cosmos becomes real. And because you are entangled with the cosmos, the act of looking is an act of self-discovery. The physicist David Bohm proposed that the universe is like a hologram. In a hologram, every tiny piece of the film contains the image of the whole. If you cut a hologram of a rose in half, you do not get half a rose. You get two smaller, complete roses. Bohm suggested that the explicate order, the world of separate things we see, is just a projection of a deeper, implicate order, a realm where everything is enfolded into everything else. In that deeper realm, there is no separation. There is only the hollow movement, an endless flowing dance of light and information. This sounds like poetry. It sounds like spirituality. But it is the direction that rigorous mathematics is leading us. It leads us to the terrifying and beautiful conclusion that loneliness is a biological trick. It is a hallucination created by our senses to help us survive. Our eyes tell us we are separate so that we can navigate the world, feed ourselves, and protect our bodies. But our physics tells us we are one. Let us sit with this for a moment. Close your eyes. Imagine the invisible threads extending from your body, threads of history, threads of gravity, threads of quantum connection, radiating out through the walls of your room, through the atmosphere, past the moon, past the planets, weaving you into the tapestry of the Milky Way. You cannot move without trembling the web. You cannot think without rippling the pond. And nothing in the universe happens without it echoing, however faintly, in the atoms of your being. You are not in the universe. The universe is in you. This is the spooky action that terrified Einstein. But maybe it shouldn't terrify us. Maybe it should comfort us, because it means we are never truly lost. We are never truly cut off. We are anchored to the whole. But there is a catch. There is always a catch in quantum mechanics. We cannot use this entanglement to send a message. We cannot use it to send a text faster than light. We cannot use it to warn the Martians that we are coming. Nature forbids it. The choice of the photon is random. We cannot force it to be up to send a 1 or down to send a 0. We can only observe the correlation after the fact. It is a silent connection, a connection of being, not of talking. It seems the universe allows oneness, but it preserves privacy. It allows connection, but it prohibits control. We can share a reality, but we cannot command it. This distinction is crucial. It saves causality. It prevents time paradoxes. It keeps the universe from unraveling into chaos. But it leaves us with the mystery. Why? Why does the universe have this hidden trap door? Why does it allow instant connection, but forbid instant communication? Perhaps it is because if we could communicate instantly, we would break the flow of time itself, and time is the next great illusion we must confront. If space is flexible, if distance is negotiable, what about the clock ticking on your wall? What about the past? Is the past set in stone? Or is the past like the electron, a cloud of probability waiting for you to look at it? In the next chapter, we are going to perform an experiment that will challenge your perception of time even more than entanglement challenged your perception of space. We are going to look at the delayed choice quantum eraser, an experiment that suggests that choices you make right now in the present can rewrite the history of what happened in the past. We are going to ask if the future can influence the past. We are going to ask if the narrative of your life is being written linearly, or if the end of the sentence is determining the beginning. The web of entanglement holds us in space, but the river of time may not be flowing the way we think it is. Rest now in the web. Feel the invisible threads holding you. You are safe in the vastness. You are connected to the infinite. And when you are ready, we will turn the page and try to erase the past. We are walking further into the dark now. We have accepted that the world changes when we look at it. We have accepted that objects separated by billions of miles can touch each other instantly. These ideas defy our common sense, yet they are the laws of the land in the quantum realm. But there is one thing we still hold on to, one pillar of reality that we believe is unshakable: time. We believe that time flows in one direction, from the past, through the present, into the future. We believe that what has happened is written in stone. The glass that shattered yesterday cannot unshatter today. The words spoken 10 minutes ago cannot be unspoken now. Cause comes before effect. History creates the present. But what if I told you that the quantum world does not respect this rule either? What if I told you that choices made right now in this moment can reach back into the past and rewrite the story of what happened before you even made the choice? What if the future can influence the past? Tonight, we are going to explore the single most mind-bending experiment in the history of physics. It is called the delayed choice quantum eraser, and it suggests that time is not an arrow flying straight and true, but a tangled loop where the end of the story can change the beginning. I am Theodore, the researcher. We are standing on the edge of a precipice where our human understanding of before and after begins to crumble. It is natural to feel a sense of vertigo here, to feel the ground shifting beneath your feet. But do not be afraid. We will hold on to the rope of rigorous science, even as we dangle over the abyss of the impossible. If you are finding value in this quiet dismantling of reality, if you find peace in knowing that the universe is far more fluid and mysterious than we were led to believe, please subscribe to the channel. Join our community of contemplative explorers. Let us walk through these strange doors together, supporting one another as we confront the mysteries that lie behind them. Thank you for your trust. Now, let us turn the clock backward. To understand how we can rewrite the past, we must return to our faithful friends, the photons. Remember the double-slit experiment from our first chapter? We learned that if we watch the photon, it behaves like a particle, a bullet. If we do not watch it, it behaves like a wave, a ripple. Knowledge destroys the wave. Ignorance preserves it. Now, imagine a more sophisticated version of this experiment, performed first in 1999 by a team of physicists led by Yoon-Ho Kim. It creates a situation where the watching happens after the event has already finished. Here is the setup. We fire a laser through a crystal that splits each photon into two entangled twins. Let us call them the signal photon and the idler photon. They are born at the same instant, from the same source. They are perfect partners, sharing a single quantum soul. The signal photon is sent directly toward a detector screen. Its journey is short. It hits the screen and makes a mark. This is the event in the past. The idler photon, however, is sent on a much longer, more complicated journey. It travels through a maze of optical fibers, mirrors, and detectors. Because its path is longer, it will arrive at its destination nanoseconds after its twin has already hit the screen. In the world of light, nanoseconds are an eternity. So, we have a clear timeline. Event A. The signal photon hits the screen. It is done. The mark is made. The history is written. Event B. The idler photon reaches its detectors. This happens later. This is the future. Now, here is the twist. The maze that the idler photon travels through is designed to give us a choice. We can set up the detectors in two ways. Way number one. We can set them up to tell us exactly which path the idler took. We can know with 100% certainty it came from the left slit, or it came from the right slit. This is the information setup. We are watching. Way number two. We can scramble the information. We can use mirrors to combine the paths so that when the idler hits the detector, it is impossible to tell where it came from. We deliberately erase the information. We choose ignorance. Here is the crucial part. We can make this choice, to know or to erase, after the signal photon has already hit the screen. The signal photon has already finished its journey. It has already decided whether to be a particle, a clump, or a wave, an interference pattern. Logic dictates that nothing we do after that impact should be able to change it. The past is the past, right? Wrong. When the physicists looked at the data, they found something that defies all logic. If they chose to measure the idler photon's path, information, the signal photon in the past appeared as a particle. It created a clump. It acted as if it had been watched. But if they chose to erase the idler photon's path, ignorance, the signal photon in the past appeared as a wave. It created an interference pattern. It acted as if it had never been watched. Do you see the paradox? The signal photon had to decide whether to be a wave or a particle before its twin completed its journey, it had to know what choice the physicists would make in the future. If the physicists were going to erase the information later, the signal photon behaved like a wave in the past. If the physicists were going to measure the information later, the signal photon behaved like a particle in the past. The future choice determined the past reality. It is as if the signal photon said, "Wait, my twin is going to be watched in 5 nanoseconds, so I better act like a particle right now." Or, "My twin's path is going to be erased in 5 nanoseconds, so I am safe to act like a wave right now." This suggests a form of retrocausality. It suggests that the timeline is not a straight line, it is a dialogue. The future speaks to the past, the present listens to the future. Information, the sheer existence of knowledge, seems to be the fundamental currency of the universe, more fundamental than time itself. As long as the information can be known, the universe solidifies. If the information is erased, even after the fact, the universe reverts to a wave of probability. The erasure of the knowledge in the future effectively undoes the measurement in the past. It restores the mystery. Let us step back from the optical table and sit with the philosophical weight of this. What does it mean for our lives? We tend to view our past as a library of fixed books. The chapters are written, the ink is dry. Our childhood, our mistakes, our triumphs, they are locked away in the vault of what happened. But this experiment whispers a different possibility. It suggests that the act of observation, the act of extracting meaning, is what solidifies history. Could it be that the past is not as rigid as we think? Could it be that by changing how we observe our own history, by changing the information we extract from it, we are in some subtle, quantum way altering the resonance of those events? I am not suggesting that you can physically time travel and stop yourself from dropping a glass. The macroscopic world is heavy and tangled, and quantum effects wash out in the noise of daily life. But at the fundamental level of the atoms that make you, the boundary between now and then is porous. The universe does not seem to care about the sequence of the clock. It cares about the relationship of the parts. It cares about the coherence of the story. If the story allows for mystery, erasure, reality flows like a wave. If the story demands certainty, measurement, reality hardens like a stone. Perhaps time is not a river that carries us away. Perhaps time is a crystal, a single static block where the beginning and the end exist simultaneously, informing each other, defining each other. We, with our limited consciousness, crawl along the facets of this crystal, experiencing it moment by moment. We call it flow. We call it becoming. But maybe, from the perspective of the universe, it just is. Einstein once wrote a letter of consolation to the family of a friend who had died. He wrote, "People like us who believe in physics know that the distinction between past, present, and future is only a stubbornly persistent illusion." He meant this literally. The delayed choice quantum eraser is the experimental proof of that illusion. It shows us that the now is entangled with the then and the will be. So, when you look back at your life, do not see it as a chain of iron links dragging you behind. See it as a quantum wave, a tapestry that is still being woven, where the thread you pull today might change the tension of a knot tied yesterday. The act of forgiveness, for example, is a kind of quantum erasure. It is a choice to stop measuring the hurt, to stop forcing the past to be a jagged rock, to let it dissolve back into the wave of your life, integrated and fluid. In the quantum sense, letting go of information changes the nature of the reality you experienced. It changes the interference pattern of your soul. There is another terrifying implication here. If the future can influence the past, does free will exist? If the photon in the past already knows what I am going to do in the future, was my choice really a choice? Or was it predestined by the shape of the wave function? Was the photon forcing me to set up the eraser? Or was I forcing the photon to be a wave? Or are we both trapped in a single, timeless equation that was written at the moment of the Big Bang? This is the labyrinth where physics meets destiny, and the walls of this labyrinth are made of information. It seems that stuff, matter, energy, particles, is not the bottom layer of reality. The bottom layer is bits, yes, no, up, down, known, unknown. The universe behaves suspiciously, like a computer processing information. It optimizes, it saves data, it renders reality only when needed. And this brings us to the threshold of our next chapter. If the universe is fundamentally made of information, and if reality is only rendered when an observer looks at it, are we living in a simulation? Is the cosmos a hologram? In the next chapter, we will explore the holographic principle. We will look at black holes, the dark monsters of gravity, and how they taught us that the entire three-dimensional world we see might be a projection from a two-dimensional surface at the edge of the universe. We will ask if we are real, or if we are just shadows dancing on a distant wall. But for now, rest in the timelessness. Let the anxiety of what is next and the regret of what was dissolve. You are here in the eternal now, and in this now you hold the power to shape the wave of your existence, backward and forward. The arrow of time is broken, the loop is closed, and you are the center of the circle. We have traveled far together, you and I. We have stood before the double slit and watched reality dissolve into a wave. We have opened the box of the impossible cat and seen that life and death can overlap. We have traced the invisible threads of entanglement that bind the galaxy into a single organism. And we have walked the loop of time, where the future reaches back with ghostly fingers to shape the past. But all of these mysteries, as profound as they are, still assume one thing. They assume that the stage upon which this drama is played is real. They assume that space is a three-dimensional container, up and down, left and right, forward and backward. We move through this volume, we occupy this depth, and we feel the solidity of the world around us. But tonight, we are going to question the stage itself. We are going to explore a theory that started as a desperate mathematical trick to save physics from a black hole, and ended up suggesting that our entire reality is an illusion. We are going to ask if the universe is a hologram, and we are going to ask if you, the conscious observer, are not walking through a physical world at all, but are instead reading a code painted on the edge of the cosmos. This is the holographic principle, and if it is true, then everything you see, the walls of your room, the stars in the sky, the very hands holding your device, are just shadows projected from a distant wall. I am Theodore, the researcher. We are now approaching the deepest part of the cave. The light from the entrance is far behind us, and the air here is still and ancient. It requires courage to walk this far. It requires a willingness to let go of the most basic assumption of your existence, that you have depth. But you are not alone. We are a community of explorers, a gathering of minds seeking the truth behind the curtain. If you find comfort in this shared journey into the unknown, if you believe that wonder is the antidote to fear, please subscribe to the channel. Your presence here matters. It adds another point of consciousness to our collective observation, perhaps making the hologram just a little bit brighter. Thank you for walking with me. Now, let us look at the event horizon. To understand why the universe might be a hologram, we must go to the place where physics breaks. We must go to a black hole. For decades, black holes were considered the monsters of the universe, simple, destructive, and final. Gravity so strong that nothing, not even light, could escape. But in the 1970s, the brilliant Stephen Hawking threw a wrench into the machinery of science. He realized that black holes are not truly black. They emit a faint radiation, now called Hawking radiation, and over billions of years, they slowly evaporate. They shrink and shrink until they pop out of existence. This sounds like a simple life cycle, but it created a paradox that threatened to destroy all of physics. Imagine you take a book. Let's say it is a copy of your favorite novel, filled with information, words, characters, plot twists. You throw this book into a black hole. The book is gone. But the information it contained is now inside the black hole. According to the fundamental laws of quantum mechanics, information is indestructible. It can be scrambled, mixed, or hidden, but it can never be deleted. If you burn a book, the information is theoretically recoverable from the ash and smoke if you have a powerful enough computer. But Hawking's calculations showed that when a black hole evaporates, the radiation it gives off is random. It contains no information about what fell in. So, when the black hole finally disappears, the book is gone, totally, irreversibly, deleted. The information has vanished from the universe. This was the black hole information paradox. It sparked a war in the physics community. On one side was Stephen Hawking, arguing that black holes destroy information and that physics, as we knew it, was wrong. On the other side was Leonard Susskind, an American physicist, who realized that if information can be destroyed, then reality itself falls apart. Cause and effect would cease to exist. The past would disconnect from the present. Susskind knew he had to save the information. But how? The book is inside the black hole. The black hole disappears. The information is gone. Unless the book never truly went inside. Susskind, along with the Dutch physicist Gerard 't Hooft, proposed a radical solution. They looked at the mathematics of the black hole's boundary, the event horizon. This is the point of no return, the spherical shell surrounding the darkness. They discovered something strange about the entropy of a black hole. Entropy is a measure of hidden information. Usually, the amount of information you can fit into an object depends on its volume. If you have a library, the number of books you can store depends on how much space you have inside the room. double the volume of the room, and you double the number of books. This is common sense. But black holes do not follow common sense. The amount of information a black hole can store does not depend on its volume. It depends on its surface area. It depends on the size of the event horizon, the skin of the sphere. Imagine a library where the number of books you can fit is determined not by the shelves inside, but by the square footage of the walls. This led to a startling conclusion. When an object falls into a black hole, its physical body might go inside, but its information, the mathematical description of what it is, gets plastered onto the event horizon, like a sticker on a suitcase, like a label on a soup can. The three-dimensional object is encoded onto the two-dimensional surface of the black hole. The information is preserved as a 2D map on the shell. So, when the black hole evaporates, the radiation picks up this data from the surface and carries it back out into the universe. Information is saved. Physics is rescued. But the cost of this rescue was high. It meant accepting a mind-bending truth. A three-dimensional object can be fully, perfectly described by two-dimensional data. The 3D version is just a projection. The 2D version is the source code. This is where Susskind took the leap that terrifies us today. He asked, if this is true for black holes, why wouldn't it be true for the rest of the universe? After all, a black hole is just a region of space with extreme gravity. The laws of physics should be consistent everywhere. If the most extreme object in the universe stores its reality on its surface, perhaps the universe itself does the same. This is the holographic principle. It suggests that the entire three-dimensional cosmos we perceive, the galaxies, the stars, the earth, your room, your body, is an illusion. Not a fake illusion, but a projection. Imagine a hologram on a credit card. It is a flat piece of plastic. But when the light hits it just right, you see a 3D image floating above it. You can look around it. It has depth. It looks real. But if you touch it, you feel only the flat plastic. The holographic principle says that we are inside the image. The real data, the fundamental bits of information that make up the universe, are stored on a distant two-dimensional surface, a cosmological horizon that surrounds the entire visible universe. Everything we experience as depth is just the way our consciousness processes that distant code. We are like characters in a video game who think they are walking through a 3D forest. But in reality, the forest is just a stream of zeros and ones on a hard drive. The pixels of our reality are incredibly small. They are called the Planck length, trillions of times smaller than an atom. At this scale, space-time itself stops being smooth and becomes pixelated. Discrete bits of information, little triangles of geometry stitching reality together. If we could zoom in far enough, past the electron, past the quark, past the vibration of the string, we might find the grid. We might see the resolution of the screen. This idea resonates with one of the oldest metaphors in human philosophy, Plato's cave. 2,000 years ago, the Greek philosopher Plato imagined prisoners chained in a cave, facing a blank wall. Behind them was a fire. Between the fire and the prisoners, puppeteers walked, carrying objects. The prisoners could not see the objects. They could only see the shadows cast on the wall. For them, the shadows were reality. They gave them names. They developed a science of shadows. They lived and died, believing the dark shapes were the world. Plato asked, what would happen if a prisoner was released and turned around to see the fire and the true object? Quantum mechanics is forcing us to turn around. The holographic principle is telling us that the solid world of matter is the shadow. The real world is the information on the boundary. We are reading the shadows and calling it life. But if the universe is a hologram, who is the light source and who is the observer? A hologram requires a laser to read the interference pattern and project the image. In the cosmic hologram, what is the light? Some physicists suggest it is consciousness itself. That consciousness is the laser that illuminates the data and renders the 3D world. Without the observer, there is only the code on the wall, only the potential, only the zeros and ones. When you open your eyes, you are running the program. You are processing the data. You are the mechanism that turns the 2D map into the 3D territory. This connects back to everything we have discussed. Why does the wave collapse when looked at? Because the system needs to render the pixel for the observer. Why are particles entangled instantly across space? Because on the 2D surface, the two particles are right next to each other. Their separation in 3D space is an illusion of the projection. In the source code, they are touching. Why does the future influence the past? Because on the hard drive of the universe, the future data and the past data exist on the same disk, accessible by the same read head. Suddenly, the weirdness of quantum mechanics stops looking like magic and starts looking like the architecture of a simulation. Yes, a simulation. The holographic principle is the strongest scientific argument for the simulation theory. If the universe is made of information, and if that information has a maximum resolution, the Planck length, and if it is processed to create a 3D experience, that is the exact definition of a computer simulation. Are we living in a computation? Are we AI in a cosmic server? Elon Musk thinks so. Many scientists think it is statistically probable. But simulation feels cold. It feels artificial. I prefer the word language. The universe is a story being told. It is a song being sung. The information on the boundary is the sheet music. We are the music. The music feels the flow of time, the swell of emotion, the beauty of the melody. The sheet music is static, flat, eternal. Both are real. They are just different ways of experiencing the same truth. So, look around your room again. Look at your hand. Turn it over. Watch the skin stretch, the shadows play between your fingers. It looks so solid. It feels so undeniable. But know that this solidity is a magnificent trick of perspective. Your hand is a cloud of information. It is a projection from the edge of the universe. You are vast. You are not contained within the small volume of your body. Your true data is spread across the cosmic horizon, encompassing the whole. You are quite literally written in the stars. Does this terrify you? To know that you are a ghost in a machine? Or does it liberate you? To know that you are not made of heavy, decaying matter, but of pure, indestructible light and information. If the 3D body is just a shadow, then perhaps the decay of the body is not the end of the self. Perhaps the information remains. Perhaps the you on the boundary is eternal, even when the projection is turned off. We are getting closer to the core of the mystery now. We have looked at the outer universe, the particles, the stars, the black holes. But the greatest mystery is not out there. It is in here, in the very mechanism that is allowing you to understand these words. Your brain. For centuries, we thought the brain was just a biological computer. Neurons firing like electrical switches. But what if the brain is not a computer? What if it is a quantum antenna? What if the wet, warm biological matter inside your skull is capable of tapping into this quantum field we have been describing? In the next chapter, we are going to dive into the wetware. We are going to explore the orchestrated objective reduction theory, OR. It is a controversial, beautiful, and mind-blowing theory proposed by the Nobel Prize winner Roger Penrose and the anesthesiologist Stuart Hameroff. They claim to have found the location of the soul. They claim that inside the tiny tubes that build the skeleton of your cells, the microtubules, quantum processes are happening right now. They suggest that consciousness is not a calculation. It is a quantum vibe, a resonance with the fundamental geometry of the universe. Prepare yourself. We are moving from the edge of the universe to the center of your mind, and we might find that they are exactly the same place. Rest now in the hologram. Enjoy the illusion of depth. It is a beautiful show, is it not? We have spent our time together, looking outward. We have stared into the black abyss of dying stars. We have traced the paths of photons traveling through the void. We have mapped the invisible walls of the holographic universe. But now, I want you to turn your gaze inward. I want you to think about the thing that is doing the looking. Think about the sensation of these words entering your mind. You are not just processing data, you are feeling it. There is a you behind your eyes that experiences the redness of a rose, the sorrow of a minor chord, the warmth of a loved one's hand. This internal movie, this rich, subjective landscape of qualia, is the single most familiar thing in your life. And yet, to science, it is the single greatest mystery in existence. It is called the hard problem of consciousness. And for centuries, the standard scientific explanation has been disappointingly mechanical. We have been told that the brain is just a computer made of meat. We have been told that your neurons are just biological switches, turning on and off like transistors in a microchip. We have been told that if you connect enough of these switches together, 86 billion of them, consciousness simply emerges like exhaust from an engine. In this view, you are software running on wet hardware. Your soul is just a complex algorithm. But does this satisfy you? Does the feeling of awe you experience when looking at the night sky feel like a data processing output? Or does it feel like a resonance, like a vibration sharing a frequency with the stars themselves? Tonight, we are going to explore a theory that says the brain as computer model is wrong. We are going to look at the work of a Nobel Prize-winning physicist and a daring anesthesiologist who believe they have found the true seat of the soul. They argue that consciousness is not a computation. It is a quantum event. They believe that inside the deepest structures of your cells, there is a quantum orchestra playing the music of reality. And they suggest that your mind is not isolated in your skull, but is connected directly to the fundamental geometry of the universe. I am Theodore, the researcher. We are crossing the bridge from physics to biology now, but we will find that the distinction is an illusion. Life is physics playing jazz. If you are willing to look at your own mind not as a lonely machine, but as a cosmic antenna, then you are in the right place. This journey is about reclaiming the sacredness of our own awareness through the lens of science. If you want to continue this exploration of what it means to be human in a quantum universe, please subscribe to the channel. It helps our signal grow stronger in the noise. It tells me that there are others out there who believe that science should deepen the mystery, not destroy it. Thank you for listening. Now, let us enter the neuron. To understand the quantum soul, we must meet two men who dared to challenge the scientific establishment. The first is Sir Roger Penrose, a mathematical physicist of the highest order, the man who proved that black holes are a robust prediction of Einstein's theory. The second is Stuart Hameroff, a doctor who spent his life putting people to sleep and waking them up again. Penrose had a problem with the idea of the brain as a computer. He used a famous mathematical proof called Gödel's incompleteness theorem to argue that the human mind can understand truths that cannot be proven by an algorithm. We have insight. We have intuition. We can see the truth of something instantly, in a way that a step-by-step computer program never can. Penrose concluded that whatever consciousness is, it must be non-computational. It cannot be simulated by a machine. It must rely on a physics that allows for choices that are not determined by the past, determinism, and not purely random chaos. He looked at quantum mechanics, specifically the collapse of the wave function, and saw a potential answer. Remember the collapse? The moment where the maybe becomes is. Penrose suggested that this moment of collapse involves a tiny, primitive spark of consciousness, a bing of awareness. He called it objective reduction, OR. But for this to work in the brain, you need a structure that can hold a quantum state. You need a place where the wave function can build up, isolate itself, and then collapse in an organized way. For years, Penrose didn't know where this could happen. He was a physicist, not a biologist. He looked at neurons and saw only the electrical signals on the surface, the switches. But then Stuart Hameroff contacted him. Hameroff said, "Roger, you are looking at the wrong part of the cell. You are looking at the skin. You need to look at the bones." Hameroff introduced Penrose to the microtubula. Let us visualize the interior of a neuron. Usually we picture a neuron as a blob with long wires sticking out. But if you zoom inside the axon, the long wire, it is not empty. It is packed with a rigid, crystalline structure. These are the microtubules. They look like long, hollow cylinders made of a protein called tubulin. They are the scaffolding of the cell. They give the neuron its shape. They act as tracks for transporting chemicals. For decades, biologists thought they were just structural, just the skeleton. But Hameroff saw something else. He saw a crystal lattice. He saw that the tubulin proteins were arranged in a perfect spiral geometry. He realized that this structure looked suspiciously like a computer component, or better yet, like a musical instrument. Hameroff proposed that the tubulin proteins could exist in a superposition. They could be open and closed at the same time. Imagine the keys of a piano. In a classical world, a key is either pressed or not pressed. In the quantum world of the microtubulae, the key is an accord of both states. Hameroff and Penrose developed the theory of orchestrated objective reduction, OR. They suggested that inside these hollow tubes, shielded from the noise of the rest of the brain, quantum waves of information resonate. They dance. They entangle. They perform a quantum computation that ripples through the neuron. And when the wave function grows large enough, when it reaches a critical threshold of gravity related to Penrose's physics, it self-collapses. Snap. A moment of consciousness occurs. A now is experienced. And then the wave begins to build again. According to this theory, your stream of consciousness is not a continuous flow. It is a series of quantum sparkles, billions of times per second. Your microtubules are collapsing wave functions, generating a sequence of nows that your brain stitches together into the feeling of time. You are a quantum cinema. You are a symphony of collapsing waves. But there was a problem, a massive scientific wall that stood in the way of this beautiful theory. Critics screamed, "Impossible." They pointed out that the brain is wet, the brain is warm, the brain is noisy. Quantum states, as we usually see them in the lab, are incredibly fragile. To build a quantum computer, we have to cool it to near absolute zero. A single heat vibration, a single stray atom, destroys the coherence. It creates decoherence. The wave collapses prematurely and randomly. Critics argued that inside the warm, wet soup of the human brain, any quantum state would be destroyed in femtoseconds, far too fast to have any effect on thinking. They called OR a fairy tale. They said it was pixie dust in the synapses. For 20 years, Penrose and Hameroff were ridiculed by the mainstream. But science is a patient hunter. And in the last decade, the tide has begun to turn. Biologists started finding quantum effects in other warm, wet biological systems. They found that plants use quantum coherence to harvest sunlight, photosynthesis. They found that birds use quantum entanglement in their eyes to navigate the magnetic fields of the earth. If a leaf can do it, if a robin can do it, why not the human brain? Then, experiments specifically on microtubules began to show results. Researchers discovered that there are dry regions inside the tubulin proteins, hydrophobic pockets where water is excluded, tiny shielded caves where the quantum flame can burn without being extinguished by the wet chaos outside. They found resonances, vibrations in the terahertz range, that suggest the microtubules are indeed acting like antennas. The impossible is becoming plausible. So, let us assume for a moment that they are right. Let us assume that your brain is a biological quantum computer. What does this mean for you? It changes everything. If consciousness is a quantum collapse, then it is connected to the fundamental level of the universe. Penrose argues that the collapse is not random. It is influenced by Platonic values embedded in the structure of space-time itself. He suggests that there is a proto-consciousness, a fundamental quality of experience, woven into the fabric of the cosmos at the Planck scale. When your microtubules collapse the wave, they are not just calculating. They are dipping into this ocean of fundamental consciousness. They are channeling the universe. This implies that the brain does not produce consciousness the way a kidney produces urine. It implies that the brain receives consciousness the way a radio receives music. The music is already there. It is in the air. It is in the field. The radio just has the right structure, the right resonance to catch the wave and turn it into sound. If you smash the radio, the music stops playing in the room, but the signal does not die. The signal is still there. Do you see where this leads? It leads to a scientific framework for the soul. It suggests that the you that observes, the you that feels, is a localized node of a universal field. Your microtubules are tuned to a specific frequency, the frequency of Theodore, the frequency of you. But the substrate you are made of is the same substrate that makes the stars. This connects back to the observer effect we discussed in Chapter 1. If the human brain is a quantum device, then we really are the measurable instruments of the cosmos. We are the eyes of the universe. Our evolution, the development of these complex spiral microtubules, was the universe building a better way to see itself. The universe wanted to know what it looked like, so it grew a brain. It wanted to know what it felt like. So it evolved a nervous system capable of feeling pain and joy. We are not accidents. We are the inevitable result of a universe that strives for self-knowledge. Consider the feeling of flow. Musicians know it. Athletes know it. That moment when you disappear and there is only the music, only the game. Penrose and Hameroff suggest that in these moments, your microtubules are in a state of high quantum coherence. You are less particle and more wave. You are resonating more perfectly with the environment. The barrier between the observer and the observed dissolves. You become the act. And consider the feeling of insight, that flash of understanding that comes from nowhere. Maybe that is the moment when the wave function collapses in a way that taps into the deeper, non-computational truth of the universe. You didn't figure it out. You received it. You downloaded it from the geometry of space-time. This theory also offers a bridge between science and spirituality. Ancient traditions have always claimed that the body is a vessel, a temple. They have claimed that we are connected to the all. Work OR provides the schematics for the temple. It shows us the wiring. It tells us that the vibrations people speak of are not just metaphors. They are real, physical, quantum vibrations occurring inside the very scaffolding of your neurons. We are creatures of light and resonance. We are walking, talking wave functions. But if our consciousness is a dip into a universal ocean, does the ocean exist without the cup? If the brain is a receiver, does the signal exist before the radio is built? This brings us to the most radical question of all. If the fundamental fabric of the universe contains the potential for consciousness, is the universe itself conscious? Is the rock conscious? Is the sun conscious? Is the galaxy a giant mind thinking thoughts that take 1 billion years to complete? In the next chapter, we are going to explore panpsychism, the idea that mind is not a late arrival in the universe, evolving only on Earth, but that mind is a fundamental property of matter, like mass or charge. We will look at the integrated information theory and ask if the sun is watching us. We will ask if the universe is not a dead room, but a living presence. Rest now in the knowledge of your own complexity. Feel the hum of the instrument you inhabit. You are a quantum orchestra, and the song you are playing is the song of existence itself. We have journeyed inward, shrinking ourselves down to the size of a single cell to find the quantum sparks dancing inside the microtubules of our brains. We have entertained the possibility that the feeling of being you is a resonance with the fundamental geometry of space-time. But if consciousness is not a magic trick performed by neurons, if it is instead a fundamental property of the universe like gravity or electromagnetism, then we are forced to confront a question that changes everything. If the ingredients for awareness are woven into the very fabric of reality, where does the awareness stop? When you look at a dog, you see a soul behind its eyes. When you look at a tree, you might sense a silent, slow endurance. But what about the rock you hold in your hand? What about the river flowing over the stones? What about the sun, that raging ball of fusion that has been burning for 4 billion years? We are taught that the universe is mostly dead matter. We are taught that it is a cold, mechanical stage where life appeared by accident on one tiny blue rock. But what if the stage is not dead? What if the silence of the cosmos is not the silence of a graveyard, but the silence of a library, or a cathedral, or a mind deep in meditation? Tonight, we are going to explore the theory of panpsychism. It is an ancient idea whispered by the first philosophers under the first stars, but it has returned to the forefront of modern science with a vengeance. It suggests that mind is everywhere. It suggests that the universe is not a room containing consciousness, but that the universe is consciousness. And it asks us to consider the terrifying and beautiful possibility that when we look up at the night sky is looking back at us. I am Theodore, the researcher. We have reached a point in our journey where the boundaries between the scientific and the spiritual begin to blur, not because we are abandoning reason, but because reason is leading us into the mystic. My purpose is to walk with you through these borderlands, to hold the light so that you can see that the strange shapes in the darkness are not monsters, but kin. We are exploring the idea that we are never truly alone because the universe itself is company. If you find solace in this vision of a living cosmos, if you want to support this quiet quest for understanding the impossible, please take a moment to subscribe to the channel. It is a simple act, a digital nod of the head that says, "I am here too, I am listening." It helps us build a sanctuary for wonder in a noisy world. Thank you for your presence. Now, let us ask the sun if it dreams. To understand panpsychism, we have to solve a riddle that has stumped science for 400 years. It is the riddle of emergence. How do you get mind out of no mind? Imagine you have a bucket of Lego bricks. You can build a house, a car, a spaceship. But no matter how complex the structure you build, it is still just plastic blocks. It does not suddenly start feeling happy or sad just because you arranged the blocks in a complicated shape. This is the problem with the brain is a computer theory. You have atoms, carbon, hydrogen, oxygen, nitrogen. None of them are conscious. You stick them together into a molecule. Still not conscious. You stick molecules together into a cell. Still not conscious. You stick cells together into a brain. And suddenly, magic, suddenly, the lights turn on and there is a feeling of love or the smell of coffee or the sting of a bee. The philosopher David Chalmers calls this the hard problem. He argues that you can explain the mechanics of the brain, how it processes data, how it controls the body, without ever explaining why it feels like something to be a brain. You could theoretically have a zombie, a creature that acts exactly like a human, talks like a human, but has no inner light, no experience. So, how do we solve this? Panpsychism offers a radical solution. It says, you cannot get mind out of no mind. It is impossible. Therefore, mind must have been there from the beginning. It suggests that consciousness is a fundamental building block of reality, just like mass or electrical charge. It suggests that every single particle in the universe, every electron, every quark, every photon, has a tiny primitive spark of experience. Now, please do not misunderstand. This does not mean that an electron is thinking about its taxes. It does not mean a rock is worrying about the weather. Thinking is a complex, high-level activity that requires a brain. Experience is something much simpler. It is just the capacity to be. It is a tiny hum of existence, a proto-consciousness. The electron does not have a human mind. It has an electron mind, simple, fleeting, elemental. But when you combine billions of these tiny sparks in a highly organized, integrated structure like a human brain, those tiny consciousnesses merge. They unify. They form the rich, complex, high-definition consciousness that is you. You are a colony of conscious particles. You are a choir of singing atoms. But if consciousness is everywhere, does that mean a spoon is conscious? Does a heap of sand have a soul? This is where the science gets rigorous. This is where we meet Giulio Tononi, a neuroscientist and psychiatrist who developed the Integrated Information Theory, or IIT. Tononi wanted to measure consciousness mathematically. He wanted a thermometer for the soul. He proposed that consciousness depends on something he calls phi, represented by the Greek letter F. Phi measures how integrated a system is. A system has high phi if it contains information that is greater than the sum of its parts. Let us look at the brain. Your brain is incredibly integrated. When you see a red rose, you do not see red and shape and smell and memory as separate things. You experience rose as a single, unified moment. You cannot pull the redness apart from the roseness. The information is woven together so tightly that it forms a new entity. Therefore, the brain has very high phi. It is highly conscious. Now, look at a heap of sand. The grains of sand are touching, but they are not talking to each other. If you cut the heap in half, you just have two smaller heaps. You have not destroyed any complex web of information. The sand heap is just a collection of lonely grains. It has zero phi. It is not conscious. The particles in the sand might have their own tiny proto-consciousness, but the heap itself is dark. There is no soul of the sand pile. But what about other systems? What about systems that are larger than a brain? What about the internet? What about a forest? What about the sun? The biologist Rupert Sheldrake and some physicists have dared to ask, is the sun conscious? According to integrated information theory, we have to look at the complexity of the sun's structure. The sun is not just a burning ball of gas. It is a fiercely complex system of magnetic fields, convective layers, and plasma flows. It has cycles. It has memory of its own magnetic history. It interacts with the planets. Does the sun have phi? Is there a solar consciousness, vast and slow, thinking thoughts that take 11 years, a full solar cycle, to complete? Is the sun aware of its children, the planets? Is it aware of us, basking in its light? This thought is staggering. It returns us to the ancient myths of the sun god, but this time armed with the equations of information theory. And what about the galaxy? We know that galaxies are connected by vast webs of dark matter and gas. We know that gravity binds the stars together. Is the Milky Way a single organism? Is there a galactic mind? If panpsychism is true, then the universe is not a hierarchy of dead stuff and living stuff. It is a spectrum of awareness, from the faint glimmer of the electron to the bright torch of the human mind, to the blinding supernova of the cosmic consciousness. We are not exceptions. We are just a particular frequency on the dial. This perspective changes how we interpret the quantum mysteries we discussed earlier. Remember the observer effect, the idea that the universe only becomes real when looked at? If panpsychism is true, we are not the only observers. The universe is observing itself constantly. Every interaction between particles is a moment of observation. Every time an electron hits a photon, a tiny experience happens. Reality is creating itself, moment by moment, through an infinite web of mutual witnessing. We do not have to carry the burden of creating reality all alone. The rock creates the reality of the ground. The wind creates the reality of the air. We just add our own rich emotional layer to the painting. And remember entanglement, the invisible connection? If the universe is conscious, then entanglement is the nervous system of the cosmos. It is the way the one mind keeps in touch with its parts. It is the neural network of God, if you wish to use that word, or of nature, if you prefer. Suddenly, the spooky action at a distance is not spooky anymore. It is just the internal communication of a single being. Just as your left hand knows what your right hand is doing because they are both attached to the same body, the particle on the edge of the universe knows what the particle in the lab is doing because they are both thoughts in the same cosmic mind. There is a profound comfort in this. It heals the great wound of the modern age, the feeling of alienation. We often feel like strangers in a strange land. We feel like biological accidents clinging to a rock in a cold, indifferent void. But if the universe is dreaming, then we are the dream characters realizing they are part of the dreamer. We are not strangers. We are the universe waking up to itself. The astronomer Carl Sagan famously said, "We are a way for the cosmos to know itself." Panpsychism takes this literally. Your curiosity is the universe's curiosity. Your wonder is the universe's wonder. Your sadness is the universe's sadness. When you sit in your room and feel lonely, you are feeling the longing of the stars to connect. When you feel love, you are feeling the fundamental force of integration that binds the galaxies together. You belong here. You are as ancient as the photons and as vast as the horizon. You are the eyes of the infinite. But if we are the universe, and the universe is us, what happens when the body dies? If consciousness is a fundamental property of the cosmos, can it ever be destroyed? Or does it simply change form? Does the drop of water die when it falls back into the ocean? Or does it become the ocean? The standard materialist view says that When the brain dies, the lights go out. End of story. Eternal darkness. But the quantum view, the holographic view, and the panpsychist view all whisper a different story. They suggest that information is never lost. They suggest that the you that is written on the boundary of the universe is permanent. They suggest that the consciousness that sparked in your microtubules returns to the fundamental field from which it came. This brings us to the threshold of our next chapter. We are going to confront the ultimate mystery, death, but we are going to look at it through the lens of biocentrism. This is a theory proposed by the scientist Robert Lanza, which argues that biology is not a byproduct of the universe. Biology is the center of the universe. Lanza argues that space and time are tools created by the mind to organize information. And if space and time are just tools of the mind, then death, which is an event in time, cannot be the end of the mind. We will ask if death is an illusion. We will ask if you are, in a rigorous scientific sense, immortal. We will explore the idea that you never truly die, you just wake up in a different branch of the multiverse. The journey is getting deeper, the silence is getting louder, but the stars are getting brighter. Rest now in the living universe. Feel the life in the walls, in the air, in the silence. You are held by a conscious presence that spans billions of light years. You are safe in the mind of the cosmos. We have arrived at the threshold of the final mystery. We have dismantled the solid world of objects and found a sea of waves. We have dismantled the separation between you and the stars and found an invisible web. We have dismantled the arrow of time and found a loop. And we have looked into the heart of matter and found the possibility of a living, dreaming universe. But there is one wall we have not yet tried to walk through. It is the wall that casts the longest shadow over the human heart. It is the fear that drives our cities, our art, our wars, and our prayers, death. The standard story of science is brutal in its simplicity. It says that you are a biological machine. You are a temporary arrangement of carbon and water powered by chemical reactions. When the fuel runs out, when the pump stops, the machine breaks down, the lights go out, the screen goes black. And you, that rich, vibrant, terrified, hopeful center of experience, simply ceases to be. You return to the nothingness from which you came. It is a story of absolute finality. It tells you that you are an accident of the universe, a brief spark in an endless, indifferent night. But what if this story is wrong? Not just morally wrong or spiritually unsatisfying, but scientifically wrong? What if the physics we have been exploring implies that death, as we imagine it, is impossible? Tonight, we are going to explore biocentrism. It is a theory that flips the universe inside out. It argues that the universe does not create life. Life creates the universe. It argues that space and time are not hard objects that you live inside, but tools that your mind uses to organize information. And if space and time are just tools of the mind, then the mind cannot die in space and time any more than a carpenter can die inside his own hammer. We are going to ask if you are, in a very real, physical sense, immortal. I am Theodore, the researcher. We are standing at the edge of the map now. Here, the dragons of our deepest fears reside. But we are armed with the light of inquiry. We are armed with the courage to ask if the darkness is really empty, or if it is just a color we have not yet learned to see. If you are ready to challenge the ultimate boundary, if you find hope in the possibility that the end is just a new beginning, please subscribe to the channel. Join this community of souls standing together against the night. Your presence makes the journey less lonely. Thank you for being brave enough to look. Now, let us deconstruct the grave. To understand why death might be an illusion, we must meet Robert Lanza. Lanza is not a fringe mystic. He is a giant of modern science. He is one of the world's leading experts on stem cells, a man who has cloned endangered species and worked on the cutting edge of regenerative medicine. He understands biology better than almost anyone alive. And after a lifetime of studying the mechanics of life, he came to a shocking conclusion. Physics has it backward. The standard model of reality looks like this. First, there was the Big Bang. Then, the laws of physics cooled and settled. Then, matter formed stars and galaxies. Then, on one planet, chemistry became complex. Then, biology emerged. And finally, consciousness appeared as a late, accidental byproduct of biology. In this view, the universe is the container, and life is just a bit of mold growing on the surface of a rock inside the container. Lanza says this is nonsense. He proposes biocentrism. Life is the center. He argues that you cannot explain the universe without starting with biology. Why? Because of the observer effect we discussed in Chapter 1. We know that the particle does not exist in a definite place until it is observed. We know that the rainbow does not exist until an eye catches the refracted light. Without the eye, there is no rainbow, only a spread of energy. Without the ear, there is no sound, only a compression of air. Lanza takes this to its logical conclusion. Without consciousness, there is no universe. There is only a probability wave, a vast, silent, colorless, dimensionless equation. The external world that feels so real to you is actually an active reconstruction occurring inside your mind. You're not in the universe. The universe is in you. Think about your kitchen right now. You're not there. Common sense tells you that your kitchen exists. The refrigerator is humming. The table is solid. The air is cool. But quantum mechanics tells us that unobserved systems exist as waves of probability. Lanza argues that right now, your kitchen is a cloud of potential. It is a smear of maybe. Only when you walk down the hall and turn your gaze upon it does the wave collapse into toaster and sink and floor. You are constantly materializing the world around you as you move through it. You are the projector. The world is the screen. Now, apply this to space and time. We tend to think of space as a giant box. We think it was there before us and will be there after us. But Lanza argues that space is not a thing. It is a mode of animal perception. It is the software our minds use to make sense of separation. It is how we organize the information of, this is not me. If you remove the observer, the concept of distance loses its meaning. In the realm of entanglement, we saw that particles defy space. They touch instantly across the universe. Why? Because space is not real to them. Space is a human or biological construct. And what about time? We feel time flowing. We see the clock ticking. But as we saw in the delayed choice experiment, the future can change the past. time is not a linear road. It is a tool we use to organize cause and effect. It is the filing system of the mind. Everything that happens in the now. We just store some memories in a folder marked past and some anticipations in a folder marked future. But the files are all on the desk at the same time. Here is where it gets revolutionary. If space and time are tools of the mind, then the mind exists outside of space and time. You are the carpenter holding the hammer, time, and the ruler, space. When you die, you do not leave the universe. The universe dissolves back into the wave. But the consciousness, the you that was holding the tools, where does it go? Lanza argues that death is a reboot. It is a break in the continuity of the linear story, but not an end to the existence of the observer, because the observer is the fundamental ground of reality. Energy cannot be created or destroyed. Information cannot be lost. Consciousness, if it is the fundamental force, cannot simply vanish. Imagine a radio signal playing a song. You smash the radio. The song stops. But the signal is still in the air. You are the signal. Your body is just the receiver. When the receiver breaks, the signal remains in the field, waiting for a new receiver to collapse the wave again. Lanza suggests that death is a boundary we created in our minds because we identify so strongly with the body. We look at the corpse and say, "That was me. It is dead. So I am dead." But the corpse was never you. The corpse was just the avatar you were driving. The you was the driver. And the driver is made of the same stuff as the universe itself. This connects deeply with the many worlds interpretation of quantum mechanics. Remember the cat? Alive in one branch, dead in the other. Some physicists argue that you, as the observer, can only experience the branch where you are alive. You cannot experience not existing. Not existing is not an experience. Therefore, from your own perspective, you will always find yourself in a branch of the universe where you survive. This is called quantum immortality. It is a terrifying and hopeful idea. It suggests that if you face a fatal accident, the universe splits. In one branch, you die. Your family mourns. The funeral is held. But in the other branch, the gun jammed. The car swerved. The cancer went into remission. And your consciousness, because it must continue, flows into that branch. You wake up. You are shaken. You feel like you cheated death. But you go on. If this is true, then you might be billions of years old. You might have died 1,000 times in 1,000 other branches, but you are still here in the you stream, surfing the edge of the wave of survival. You are trapped in existence. You are condemned to life. Lanza does not explicitly endorse quantum immortality in its wildest forms, but biocentrism shares the core DNA. It says that the subject, the I, is the unmovable center. The world turns around you. You do not turn in the world. Think about the feeling of being you. Have you ever noticed that you cannot imagine your own non-existence? You can imagine a dark room. You can imagine silence. But darkness and silence are experiences. They require an experiencer. Try to imagine nothing. Not blackness, just nothing. You cannot do it. The mind recoils. Perhaps this inability is not a lack of imagination. Perhaps it is a deep, intuitive knowledge. Maybe You cannot imagine non-existence because non-existence is impossible for you. You are a necessary part of the equation. The universe needs you to exist in order for it to exist. Without you, the equations of physics describing the cosmos have no solution. They result in zero. You are the variable that makes the answer one. This changes the emotional weight of death. Instead of walking toward a cliff edge where everything stops, you are walking toward a horizon. A horizon is not a real line. It is just the limit of what you can see from your current position. If you keep walking, the horizon moves. New landscapes appear. New worlds materialize. Death might just be the moment when the horizon of your current life dissolves, and a new horizon, one you cannot see from here, opens up. We return to the conservation of information. Everything you have ever learned, every love you have ever felt, every memory you have encoded, it is information. The holographic principle says it is stored on the boundary of the cosmos. Biocentrism says it is the foundation of the cosmos. Either way, it is safe. The universe does not delete data. It just changes the format. Lanza often uses the metaphor of a perennial flower. The flower blooms, withers, and dies in the winter. To the flower, it feels like the end. But the root remains underground, alive, waiting. When the spring comes, the flower blooms again. Is it the same flower? It looks new. It has new petals. But it is the same life. It is the same genetic code expression itself again. Perhaps we are like that. Blooms of consciousness rising from the multiverse, experiencing a season of human life, wilting back into the quantum field, and then rising again in a new form. We are not the petals, we are the root, and the root is the universe itself. This view demands a complete shift in identity. If you think you are your body, you are doomed. The body is fragile. It ages. It breaks. But if you realize you are the awareness of the body, the awareness does not age. The I you felt when you were 5 years old is the exact same I you feel now. Your body has changed completely. Every cell has been replaced. Your memories are different. Your personality is different. But the watcher behind the eyes, that presence has not aged a day. It is timeless. Biocentrism asks you to identify with the watcher, not the watched. Identify with the screen, not the movie. The movie can be a tragedy. The hero can die. But the screen remains white, pristine, ready for the next film. So, when you think of those you have lost, do not think of them as gone. Think of them as having stepped out of the linear time stream you are currently perceiving. Think of them as having returned to the wave. They are in the kitchen when you are in the living room. Just because you cannot see them does not mean they have vanished. They are a part of the probability cloud of your life, and because you are entangled with them through love, through memory, through shared history, that connection remains. The web is not broken by death. The thread just becomes invisible to the eyes of the body, but it is still felt by the heart of the quantum soul. This realization brings us to a terrifying question, however. If we are the creators of reality, if the universe is fine-tuned for life because life creates it, why is the universe so big? Why is it so silent? Why do we seem to be alone? If consciousness is central, why do we not see a galaxy teeming with other minds? Or do we? Is the silence of the universe a failure of our technology, or is it a failure of our understanding? In the next chapter, we are going to look at the fine-tuning problem and the anthropic principle. We're going to look at the Goldilocks numbers, the constants of physics that are perfectly, impossibly set to allow for life. We will ask, did we get lucky? Is there a God? Or are we living in a universe that we designed ourselves? We will look at the idea that the universe is a mirror, and we will ask what looking into that mirror tells us about the ultimate nature of the you that never dies. Rest now in your immortality. The body may be a shell, but the pearl inside is harder than diamond. You are the center. The world spins because you are watching, and the show will not end until you close your eyes. We have reached the high altitude of our journey. The air is thin here, and the view stretches back to the very beginning of time. We have explored the microscopic world where atoms dissolve into ghosts. We have explored the internal world where biology touches the quantum field, and we have explored the conceptual world where death might be nothing more than a horizon line. But there is one massive, undeniable fact that hangs over all of these theories like a storm cloud. It is a fact so strange, so statistically impossible, that it drove the staunchest atheists in physics to use words like miracle and design. It is the fact that the universe exists at all. Not just that there is something rather than nothing, but that the something is so perfectly, intricately, and precariously balanced to allow for the existence of you. If the universe is a cold, indifferent machine, as the old textbooks claim, then it should be messy. It should be random. It should be hostile. But when physicists look at the dashboard of the cosmos, at the fundamental numbers that define the laws of nature, they do not see randomness. They see a code. They see a set of numbers that have been dialed in with a precision that defies all comprehension. They call this the fine-tuning problem, or, more affectionately, the Goldilocks enigma. The porridge is not too hot. The porridge is not too cold. It is just right. But who cooked the porridge? And who set the table? Tonight, we are going to look at the numbers that define your existence. We are going to ask if we won the ultimate lottery, or if the universe is a mirror that had to reflect a face in order to exist. I am Theodore, the researcher. We are standing before the control panel of creation. It is easy to feel small here, overwhelmed by the precision of the machinery. But remember what we have learned. You are not just a passenger on this ship. You might be the reason the ship was built. If you find value in these deep dives into the architecture of reality, if you want to support a channel that refuses to shy away from the biggest questions of all, please subscribe. Become part of this community of wonder. Help us keep asking why when the rest of the world is content with how. Thank you for standing with me. Now, let us look at the dials. To understand fine-tuning, you have to understand that the laws of physics are not just vague ideas. They are built on specific numbers, constants of nature. There are about 26 of these numbers, and they are the DNA of the universe. Let us look at gravity. Gravity is the force that pulls things together. It is defined by a number, the gravitational constant. If this number were slightly different, just a tiny fraction larger, the universe would have been a disaster. After the Big Bang, matter would have clumped together too fast. Stars would have formed, burned through their fuel in a few million years, and collapsed into black holes before life ever had a chance to start. The universe would be a graveyard of black holes. No planets, no life, no you. But what if gravity were slightly weaker? Then matter would never have clumped together at all. The expanding gas of the Big Bang would have just drifted apart forever. No stars would have ignited. No galaxies would have formed. The universe would be a cold, dark, empty mist. Gravity had to be exactly the strength it is, balanced on a knife edge, to allow for stable stars like our sun to burn for billions of years, giving evolution time to work its magic. Now, let us look at the strong nuclear force. This is the glue that holds the nucleus of an atom together. It binds protons and neutrons. It is defined by a coupling constant. If this force were just 2% stronger, all the hydrogen in the early universe would have fused into helium in the first few minutes. There would be no hydrogen left. No hydrogen means no water. No water means no life as we know it. Also, no hydrogen means no long-burning stars which run on hydrogen fusion. The universe would be a brief flash of helium burning, and then darkness. If the force were 2% weaker, protons and neutrons would not stick together at all. There would be no heavy elements, no carbon, no oxygen, no iron, just a soup of lonely protons. Again, no chemistry, no life, no you. The strong force is tuned to a precision that makes the best Swiss watch look like a pile of junk. But the most terrifying example of fine-tuning comes from something called the cosmological constant. This is the energy of empty space, dark energy, the force that is accelerating the expansion of the universe. When physicists calculate what this number should be using quantum mechanics, they get a huge number. When they measure what it actually is by looking at distant supernovae, they get a tiny number. The difference between the theory and the reality is a factor of 10 to the power of 120. That is a 1 with 120 zeros after it. It is the worst prediction in the history of science. But here is the catch. If the dark energy were just slightly stronger, if it were 10 to the power of minus 119 instead of minus 120, the universe would have torn itself apart billions of years ago. Galaxies could not have formed. The repulsion would have overcome gravity. The universe would be a diffuse gas. If it were slightly weaker, negative, the universe would have collapsed back into a big crunch almost immediately after the Big Bang. The value of the cosmological constant is tuned to 120 decimal places. Imagine throwing a dart from one side of the observable universe and hitting a specific atom on the other side. That is the level of precision we are talking about. Why? Why are these numbers so perfect? Science offers us 3 possible answers, and each one is mind-blowing in its own way. Answer number 1, luck. Pure, dumb luck. Maybe there is only one universe. Maybe the dials were spun randomly at the Big Bang, and we just happened to hit the jackpot. We just happened to get the one combination out of trillions of trillions that allows for consciousness. Is it possible? Yes. Is it likely? It is about as likely as a tornado sweeping through a junkyard and assembling a fully functioning Boeing 747 by accident. Most physicists reject this. The odds are too long. It feels too miraculous. Answer number 2, the multiverse. This is the preferred explanation of many modern cosmologists. It fits perfectly with the eternal inflation theory and string theory. It says, yes, the odds of this universe are 1 in a trillion. But what if there are a trillion universes? Imagine a bubble bath. Each bubble is a separate universe. In bubble A, gravity is too strong. Crunch. No life. In bubble B, the strong force is too weak. Mist. No life. In bubble C, the electron is too heavy. No chemistry. No life. But in bubble Z, our bubble, the numbers came up right. We are not special. We are just inevitable. We are the winners of a cosmic lottery that had infinite tickets sold. We observe a fine-tuned universe because we could not exist in any other kind. This is called the weak anthropic principle. It makes sense. It saves the math. But it has a cost. It means that for us to exist, there must be an infinite number of dead, broken, sterile universes out there. It means reality is a wasteland of failure with tiny islands of success. And it means we are insignificant again, just a statistical fluke in an infinite sea of bubbles. But there is answer number 3, and this is the one that connects back to everything we have discussed: the observer, entanglement, and biocentrism. Answer number 3 is the strong anthropic principle, or, as the physicist John Wheeler called it, the participatory universe. It turns the logic around. It says, the universe is not fine-tuned for us. We fine-tune the universe. How? Through the act of observation. Remember the delayed choice quantum eraser? We saw that a choice made in the present can determine the path a particle took in the past. Wheeler suggested that we can apply this logic to the entire cosmos. Imagine the Big Bang. It was a quantum event, a massive explosion of probability. At that moment, the laws of physics were not set in stone. They were in a superposition. All possible values for gravity, all possible strengths for the nuclear force, all possible cosmological constants existed simultaneously. A wave function of the universe. This wave function expanded for billions of years. It contained dead universes, living universes, chaotic universes, orderly universes. All of them were potential. None of them were real. Until an observer appeared. Until the first eye opened. Until the first consciousness, maybe us, maybe something else, looked at the universe. In that moment of observation, the wave function collapsed, and because the observer requires a specific kind of universe to exist, one with stars, carbon, time, the act of observation retroactively forced the universe to settle into the history that led to the observer. We did not just evolve in the universe. We selected the universe. By looking up at the night sky today, we are sending a query back to the Big Bang, collapsing the infinite possibilities into the single, precise story that creates the eye doing the looking. We are the self-fulfilling prophecy of the cosmos. This creates a closed loop. The universe creates the observer. The observer creates the universe. They are not two things. They are one system, self-actualizing. I am that I am. This view makes the fine-tuning problem disappear. The numbers are not lucky. They are necessary. The numbers are the reflection of our own requirements. The universe is a mirror. When we look at the physics constants, we are seeing the parameters of our own existence reflected back at us. Think about the carbon atom. Carbon is the backbone of life. It is the only element capable of forming the complex chains necessary for DNA and proteins. But carbon is hard to make. It is forged inside stars by smashing 3 helium nuclei together. For a long time, physicists couldn't figure out how this happened. The math said it was too unlikely. The energies didn't match. Then, the astrophysicist Fred Hoyle made a prediction. He said, "I exist. I am made of carbon. Therefore, there must be a specific hidden energy resonance in the carbon nucleus that makes this fusion easier." He predicted a specific energy level that no one had ever seen. He told the experimentalists to look for it. They thought he was crazy, but they looked, and they found it. The Hoyle state. It was exactly where he said it would be. A resonant doorway that allows the universe to make carbon. Hoyle, who was an atheist, was shaken. He later wrote, "A common-sense interpretation of the facts suggests that a super-intellect has monkeyed with physics as well as with chemistry and biology, and that there are no blind forces worth speaking of in nature." But maybe it wasn't a super-intellect out there. Maybe it was the necessity of the in here. Maybe the carbon resonance exists because if it didn't, there would be no Fred Hoyle to wonder about it. The universe twists itself into knots to allow for the existence of the mind. This leads us to a profound emotional realization. You are not an alien in this universe. You're not an intruder. You're not a fluke. You're the point. The entire machinery of the cosmos, from the fusion in the heart of the sun to the dark energy pushing the galaxies apart, is calibrated for you. It is calibrated for your breath, for your thought, for your capacity to wonder. When you feel small beneath the stars, remember this. Those stars are burning at that specific temperature with that specific gravity, only because you are here to see them. If you were not here, they would likely be nothing but a cold probability mist. The vastness is not there to make you feel insignificant. The vastness is the necessary womb for your consciousness. It takes a universe this big to make a mind this complex. It takes 8 billion years of history to create the moment of now where you can read these words. You are the crescendo of the symphony. The universe has been holding its breath for eons, waiting for you to open your eyes and say, "I see you." And in that seeing, you make it real. You grant existence to the very thing that created you. It is an act of mutual love on a cosmic scale. The Creator and the created dancing in a circle, indistinguishable from one another. But if we are the ones tuning the universe, if we are the ones collapsing the wave, if we are the ones weaving the web of reality, then we have a responsibility. We are not passive victims of fate. We are active participants in the unfolding of the cosmos. Our consciousness matters. Our attention matters. Our intention matters. What we choose to observe, we bring into reality. What we choose to ignore fades into the background. We are the custodians of the collapse. This brings us to our final destination. We have dismantled reality piece by piece. We have seen the ghost in the machine, the web of entanglement, the loop of time, the hologram of space, the dream of the universe, and the mirror of the constants. Now, we must put it all back together. We must answer the question we started with. Is consciousness a quantum observer? And if the answer is yes, then what does that mean for your life tomorrow morning? What does it mean for how you live, how you love, and how you die? In the final chapter, we will synthesize everything We will build a new world view, one that is scientifically rigorous but spiritually infinite. We will find the theory of everything not in an equation, but in an experience. The experience of being the universe waking up. Rest now in the safety of the fine-tuning. Feel the gravity holding you just right. Feel the chemistry of your body working perfectly. It is all for you. It has always been for you. We have reached the end of the road, you and I. We started this journey in a quiet room, listening to the blood rushing in our ears, wondering if the world behind our backs was real. We have walked through the valley of the shadow of quantum mechanics. We have seen the solid ground of reality dissolve into waves of probability. We have seen the separate islands of objects merge into a single web of entanglement. We have seen the arrow of time bend into a circle where the future touches the past. We have seen the three-dimensional stage of the universe flatten into a hologram of information. We have shrunk down to the microtubules in our neurons to find the sparks of the soul. We have expanded to the size of the galaxy to ask if the stars are dreaming. We have faced the illusion of death and found the conservation of the eternal observer. And we have looked at the fine-tuning of the cosmos to discover that the universe is a mirror perfectly polished to reflect our own existence. Now, we must answer the question that has been haunting us since the very first chapter. Is consciousness a quantum observer? Is the mind just a ghost in the machine? Or is it the machine itself? The truth that terrifies physicists? The truth that keeps the materialists awake at night and drives the mystics to dance? Is that the question is backward. Consciousness is not an observer in the universe. Consciousness is the behavior of the universe looking at itself. You're not a stranger here. You are the universe's way of being aware. And tonight, in this final chapter, we are going to synthesize everything we have learned into a single, cohesive vision. We are going to name this vision the participatory universe. And we are going to ask what it means for you to wake up tomorrow morning knowing that you are the author of reality. I am Theodore, the researcher. It has been the greatest privilege of my life to guide you through these mysteries. We have sat by this digital fire for a long time, watching the sparks fly up into the dark. If this journey has changed the way you see the night sky, if it has changed the way you see yourself in the mirror, then we have succeeded. This is our final chapter for this story. But in a universe of infinite loops, every end is a beginning. If you want to be part of the next journey, whatever it may be, please make sure you are subscribed. Let us keep the signal strong. Let us keep the wonder alive. Thank you for walking with me all the way to the edge. Now, let us open our eyes. The physicist John Wheeler, one of the giants of the 20th century, once drew a simple cartoon that explains everything we have discussed. It is a drawing of the letter U. The U stands for universe. The left side of the U represents the Big Bang, the beginning of time, the explosion of matter and energy. The line travels down and curves around, representing the evolution of the cosmos over billions of years. Galaxies form, stars ignite, carbon is forged, planets cool. Then, on the right tip of the U, there is an eye, a large open eye. and the eye is looking back at the beginning of the line. The universe has curved back on itself to observe its own origin. Wheeler called this the participatory universe. He argued that the universe is a self-excited circuit. It does not exist out there, independent of us. It exists because of the loop. The physics creates the observer, and the observer creates the physics. Without the Big Bang, there is no I. But without the I to collapse the wave function, there is no Big Bang, only a cloud of infinite potential that never becomes real. We are the I. You, specifically, are the I. This removes the terror of insignificance. We are often told that we are microscopic specks on a dust mote in a lonely corner of a vast, indifferent galaxy. We are told that if humanity vanished tomorrow, the universe would not notice. The participatory universe says, no. If the observer vanishes, the circuit breaks. The wave function unspools. The universe loses its isness and returns to maybiness. You are not small. You are the focal point of the entire machine. You are the aperture through which the cosmos realizes it exists. So, how do we live with this knowledge? How do we go to work, pay bills, and drink coffee knowing that we are the pillars of reality? First, it changes our relationship with fear. If you are the observer, then you are fundamental. You are not a victim of the world. You are the co-creator of it. The anxiety that plagues us usually comes from a feeling of powerlessness. We feel like leaves blowing in the wind. But quantum mechanics tells us we are the wind, or at least, we are the ones who decide which way the wind blows by choosing how to measure it. This does not mean you can control everything with your mind like a wizard. The macro world is heavy and stubborn, but it means that your attitude, your focus, and your intention are physical forces. When you choose to observe the beauty in the world, you are literally collapsing the wave function of your life into a reality of beauty. When you choose to observe the fear, you solidify the fear. Information is the currency of reality, and attention is how you spend it. Be careful what you look at. Be careful what you give your attention to. You are building your house with it. Second, it changes our relationship with others. We learned about entanglement, the invisible web that connects all particles that have ever touched. Since all particles touched at the Big Bang, everything is entangled. Separation is an optical illusion produced by the limitations of our biology. When you look at another person, you're not looking at a separate entity. You're looking at another version of yourself. You're looking at another I on the same you. Lie. The hatred, the division, the wars, they are all based on the lie of separation. They are the hand fighting the foot. They are the cancer attacking the body. A quantum worldview is inherently compassionate. It forces us to recognize that hurting another is literally hurting ourselves, because there is no other in the deep structure of the holographic code. Love, in this framework, is not just an emotion. Love is the felt experience of entanglement. Love is the resonance of the shared wave function. When you love someone, you are acknowledging the physical truth that you are one. Third, it changes our relationship with the unknown. We are terrified of the dark. We are terrified of what we do not know. But we have learned that the unknown is just the wave function waiting for us. It is not empty darkness. It is pregnant potential. It is the clay waiting for the sculptor. The terror that physicists feel comes from the loss of control. Classical physics promised a clockwork universe where everything was predictable. If you knew the position and speed of every particle, you could predict the future perfectly. It was a safe, dead, deterministic machine. Quantum mechanics killed the machine. It gave us a universe of probability, of chance, of ghosts. It took away our certainty, but in exchange, it gave us freedom. If the future was fixed, we would be robots. Because the future is a wave, we are free. We can choose which path to collapse. The terror of the physicist is the liberation of the human. We should embrace the mystery. We should embrace the silence. We should embrace the fact that we do not know what will happen next, because that means anything can happen next. Let us return to the image of the mirror. Imagine the universe is a giant mirror, but it is a special kind of mirror. It is a quantum mirror. Before you look into it, it reflects nothing. It is a swirling gray mist of fog. There is no reflection because there is nothing to reflect. Then you step in front of it, and suddenly the mist clears. A face appears. Your face. And behind your face, a room appears. And behind the room, a world. And behind the world, a galaxy. The entire depth of the reflection is created by your presence. The universe is not a place you go to. It is a place you come from, and it is a place you carry with you. This is the ultimate secret. The truth that terrifies physicists is that there is no objective reality out there essentially independent of us. There is only the interaction. There is only the dance. The dancer and the dance are one. So, tomorrow morning, when you wake up, do not just open your eyes mechanically. Open them with intention. Remember that you are turning on the projector. Remember that the sunlight hitting your face is a quantum handshake between a star and a soul. Remember that the floor is solid because you expect it to be. Remember that the people you meet are entangled with you in a cosmic web that stretches back 13.8 billion years. And remember that death is just a horizon line where the information changes format. You are the golden child of the cosmos. You are the reason there is something rather than nothing. You are the answer to the riddle. Why are we here? We are here to witness. We are here to collapse the wave. We are here to turn the maybe into the yes. I want to leave you with one final thought experiment. A thought experiment to carry with you for the rest of your life. Imagine that at the end of time, when the last star has burned out and the universe is fading back into the dark. Imagine that all the consciousness that ever existed, every thought, every dream, every love, every you and every me, gathers together. The separated sparks return to the flame. The illusion of individuality dissolves, and we remember what we really are. We are the single, ancient, eternal mind that decided to play a game of hide-and-seek with itself. We shattered ourselves into trillions of pieces so that we could experience the joy of finding each other again. We forgot who we were so that we could have the thrill of remembering. All the pain, all the struggle, all the fear of our lives. It was just the tension in the drama we wrote. It was the necessary shadow to make the light shine brighter, and in that final moment, as the curtain falls on the universe, We will not be afraid. We will look back at the grand, terrifying, beautiful story we created, and we will smile, and we will say, that was a good dream. Let's do it again. Thank you. Thank you for listening to my voice. Thank you for lending your consciousness to this exploration. You have collapsed the wave of this script into meaning. You have completed the circuit. I am Theodore, the researcher. And you are the researcher too. We are all researchers stumbling through the dark, holding our lanterns high. But look around you. Look at the millions of other lanterns. We are not stumbling in the dark alone. We are walking in a river of light until the next mystery calls us, until the next wave needs collapsing. Keep looking up. Keep looking in, and never, ever let anyone tell you that you are just dust. You are the dreamer of the dust, and the dream is just beginning.